factored form. And I have an equation here, y equals negative bracket x minus 2 times x plus 4. And in factored form, you are able to determine a and the zeros, which are also your x-intercepts. In this equation, we have a is negative 1, and the zeros are positive 2 and negative 4. You can plot those points right on the grid and determine the axis of symmetry. And here's your point at positive 2, that an x-intercept, and the x-intercept at negative 4. The axis of symmetry is exactly in between your zeros, which in this case would be at negative 1. Your axis of symmetry is x equals negative 1. The axis of symmetry is your x coordinate of the vertex. And when you know the x-coordinate of the vertex, you can determine the y-coordinate of the vertex by simply substituting into the equation the value of x equals 1 and solve for the y-coordinate. Our equation, y equals negative. I'm going to substitute where the x is the value of the x-coordinate of the vertex, which is negative 1. To solve this equation, you do the brackets first. Minus 1 minus 2 is a negative 3. That's going to be multiplied by negative 1 and the value of the second bracket, which is negative 1 plus 4, which is a positive 3. When you multiply all these values together, you get negative 1 times negative 3, which is positive 3, times a positive 3 is positive 9. This is your y-coordinate of the vertex. So your vertex has coordinates negative 1 from your axis of symmetry and positive 9. Now you can write the equation in vertex form once you know the vertex. In vertex form, looks like this. The coordinates of the vertex go into the equation here and here. A, you knew from the first equation in factored form, was a negative 1. So you substitute these values in. The x-coordinate of the vertex has the opposite sign when it goes into the equation. So instead of a negative 1, it's going to be positive 1. The y-coordinate of the vertex stays the same. And you have your equation in vertex form and in factored form.